In this video, we will be starting um, our lesson on torque. We'll be answering questions regarding it. That's going to be the main basis for our practice. So, yeah, just to inform you, the exams are over. I haven't received my exam score yet, but I'm hoping for the best. I believe I mastered all of the worksheets for this exam. So, here I am to demonstrate my ability to answer these questions to you. So, a uniform ruler of 10 centimeters. So the length of the ruler is 10 centimeters. It balances horizontally about the pivot. Pivot is at the center or the midpoint. And a weight of 7 newtons is suspended at 1 centimeter mark. So this is 1.4 right here. But that won't really matter at this point. What we have to know is the distance of that mark to the pivot. So if this is 1.4 cm and this is 5 cm, 5 minus 1.4, that is 3.6. So 3.6 cm. Let's say this is weight 1. It says weight, so we'll say weight. I'll tell this to you in advance. Whenever you see force or weight, they're used interchangeably. I have to discuss to you the formula for torque now. So torque is basically equal to FD, particularly if your if your scenario is you're using a ruler. But if you're given a torque problem such as this, torque is not equal to FD simply. It is equal to FD sine theta. There's an angle involved. That's the reason why it's a little more complicated. But in the context, again, of a ruler, it's only FD. Or you can say it's WD. Either way, anything works. And another thing is that torque CC is equal to torque C, assuming that the ruler is balanced. That's because since we have two weights on different sides of the pivot, opposing sides, we want to see which way is heavier. But in this scenario, both of them, regardless of the distance and the corresponding weight, they balance out. So it says here, the scenario, the ruler is said to be balanced. So back to where we are. The weight is missing, I suppose. And yeah, we do know the distance. The 9 centimeter mark is there. 9 minus 5 is 4 cm. So 3.6 cm, that is the distance 1. This one is distance 2. This one is weight 2. Weight 2 is missing. Now, how do we solve this kind of problem? Before I move on, I still have to tell you this other formula. The net torque is equal to TC minus TCC minus TC, such that TCC is positive and T clockwise is negative. So that's going to be important. Based on what we have now, we have to write list under category by category the values that correspond to whether it's counterclockwise or clockwise. How do we know? Well, for the weight and distance here, if it's heavier, then the ruler would move in this motion. This is said to be clockwise. Therefore, distance 2 and weight 2, they are clockwise. And for counterclockwise, we have the weight and distance here. If it's heavier, then it will move like this. So that's counterclockwise. So D1 is 3.6 cm. W1 is 7 newtons. Now, we'll use a bit of algebra here. So TCC is equal to TC. You can substitute, so we have W1 D1 is equal to W2 D2. W1 is 7 newtons and D1 is 3.6 centimeters. Although I have to tell this to you also again, This is another commercial before we move on. We have to it's usually important to convert to SI units as much as possible, but right now it doesn't really matter because as with respect to our distances, both of them have the same unit, so they'll cancel out anyways. And what we're looking for is in newtons, such that the other weight is in newtons, so we don't have to convert. But just be careful if you have to convert, do so. So we have the distance 2 there, weight 2 is missing. So 7 times 3.6, and then you divide it by 4, that's going to be equal to 6.3 newtons. Just to write the complete solution, W2 is equal to 7 newtons times 3.6 centimeters divided by 4 centimeters. And as you can see, cm will cancel and you'll have the unit newtons. So no need to convert in this scenario. Next question. Why is the weight of the ruler not necessary in finding weight? Okay, I won't answer this thing. I'm not sure. Okay, number 2. I'll see what I can do in the remaining time that I have. I have like 10 minutes left to my next class. Okay, so first things first, write TCC and TC. So this is our pivot. This is the distance. Distance is said to be standard. Regardless of the distance, it's always going to be 80 centimeters. So we have 3 forces. Let's label each properly. So F1, F2, and F3. For F1, so the movement is going there, or yeah, what's the motion for that? Counterclockwise. So D1, F1 is 25 newtons, D1 is 80 centimeters. For F2, it's going away from the pivot. Regardless, I should tell you this now. Regardless if the force is going away from the pivot or directly towards the pivot, the force is said to be considered useless because it doesn't change anything. You only consider forces that either move clockwise or counterclockwise. For F3, it moves that way, so I think this is clockwise. So D1 is still 80 centimeters. Sorry, D3. And F3 is said to be 90 degrees. And so, where do we put the useless force? Maybe just to be proper, you can still write it. But in the formula, the value is going to be 0 anyways. You know why? The reason for that is, F2 is what? 20 newtons. So let's say the angle for 2 is 0. No, 180. This is just my theory. It hasn't been proven or verified by my teacher, but if the angle is useless, then it's usually 180 degrees. If the force is useless, then the angle is 180 degrees. Either way, 180. And if you try putting sine 180 in the calculator, it's always going to be 0. Just like if the angle is 0, sine 0 is equal to sine 180, if I'm not mistaken. That's a given. So, what are we looking for? Find the sum of all the torques. So, T net is equal to TCC minus TC. So, TCC is F1 D1. By the way, I almost forgot to write down the angle values. Angle 1 is this, 25 degrees. Angle 2, 180, as said earlier. Angle 3 is 90 degrees. Force 3 is supposed to be 10 newtons. I'm sorry about that mistake. F1D1 sine theta 1 minus F3D3 sine theta 3. And then for the useless force, this is optional. You can write F2D2 sine theta 2. But either way, that's going to be 0. So F1 is 25 newtons. D1 is 80 centimeters sine 25 degrees. And F3, 10 newtons. D3 is 80 centimeters sine 90. I think sine 90 is 1, basically. If I remember my pre-calculus correctly. Pre-cal or trigonometry? Doesn't really matter at this point which kind of math that falls under. So we have 845.23652 Newton meters. By the way, the unit for torque is Newton meters. Figure out why by yourself. It's pretty easy. Anyways, I almost forgot the unit there. I don't have to write that anymore. So what we have left is 45.23652 Newton meters. So what does this say? What this basically means, the force counterclockwise is stronger compared to the force of clockwise, compared to the torque of clockwise. So yeah, if the entire thing is balanced, then the T net is supposed to be 0, which is not the case here. If this value is negative, for instance, that means the torque clockwise is stronger. So that's basically it. So as you can see, hang on. I might have to check on this. It says here 0.45 Newton meters, but here it says 45. Anyways, this is going to be the last question for this video. I'll be continuing in the next one pretty soon. But where are they? Okay, this is number 2. Okay, so yeah, I think in this scenario, it's imperative to convert to meters. So 80 centimeters is 0.08 meters. Okay, so with that, eventually you will get this value, 0.04524 Newton meters. So please disregard this, it's wrong. This is the correct one. Okay, number 3 for the next video. Thanks for watching.